All right, guys, welcome back. And this is going to be the first part of the 9.7 instructional video. We're going to break it into two parts. So this will be part one. And what I want you to do to start here is I want you to factor the following. This might seem like a blast from the past. That's okay. Factor the following two trinomials. Pause the video, factor them out. Okay, so hopefully you factored them at this point. And you might have gotten, because of what we've been doing with 9.6 over and over and over again, you might have switched into autopilot, done 1 times 9, found the factors, split the middle, and gotten your answer. But remember, these are actually 9.5 problems, not 9.6 problems. Now, the good news is if you use the split the middle method here, it still works. You still get the right answer. You've just done a couple extra steps. You see here, we can take the shortcut. Since there is no coefficient in front of the x squared in either case, we can go ahead and just go straight to our c value, 9 and 25. And we can find the factors. And then from there, we can go ahead and identify which ones will give us our add to give us our middle term. So in this case, 3 and 3 would add to give you 6. 5 and 5 would add to give you 10. And I can jump straight to writing my answer as x plus 3 times x plus 3. Again, this is all due to the fact that there is no coefficient in front of the x squared. Obviously, we would need to split the middle if that were not the case. And I actually can simplify my answer a step further by writing x plus 3 squared and x plus 5 squared. Okay, so I could go one step further. Because my factors are identical, and they're multiplied together. And we know that when we multiply something by the exact same thing a number of times, we can write it as an exponent. So this would be what our answer is. And I want you to pause the video again, and I want you to see what patterns you notice. What patterns do you notice here? Well, hopefully one that you've identified is, well, probably the one I already did, which is, hey, our factors, our two binomials, turned out to be the exact same. That's a little weird, okay? And I hope you're also going, again, the typical pattern we would recognize, right? If I multiply the last two numbers, I get the last term. If I add the two numbers, I get the coefficient. So if I multiply here, whereas if I add, I get the middle number. Again, that's a pattern we often notice, and that's the basis of distributing and factoring, is that relationship where we multiply to get the last term, we add to get the middle term. But in doing this, what I really want to focus on, and the final pattern I wondered if you would notice, is you might have sat there and gone, this looks familiar. And the reality is it has, but we've seen this story actually in reverse, okay? In 9.4, we solved problems where we said, hey, I have x plus squared. Go ahead and distribute that out for me. And you did. And you got, after you distributed it all out, you would end up with x squared plus 6x plus 9. But what we did is we said, hey, because these factors are identical, there's a shortcut we can take. And that's going to be the same case here. You see, in 9.3, when it was all about distributing, we then learned how to distribute, and then we advanced to 9.4 where we distributed special cases. This being one of them. Special cases where the factors or the two binomials being multiplied together are identical. And in that case, there were some shortcuts we would take. Well, here's what we're going to say in 9.7. What we can say here is, while we're starting with the trinomial, again, if it's a special case where the trinomial factors into to identical binomials, there are special shortcuts we can take. And that's what 9.7 is going to be all about. So the case in the definition I want you to write down, the case we just examined above is called a perfect square trinomial. Why? Because our trinomial is going to factor into a perfect square. What's a perfect square? It's when something times something else are, and those two somethings are the exact same thing. Think about it like this. If I look back above, let me erase some of the mess we've got going on here. X squared plus 6x plus 9, again, to rewrite the answer, factored into x plus 3 times x plus 3, which was x plus 3 squared. The trinomial factored into a perfect square, where two of the exact same thing are multiplied together. Okay, so it's called a perfect square trinomial because the trinomial factors into a perfect square, namely x plus 3 squared. So there's some of your background. Let's get into the actual problem solving. So what are these shortcuts I'm speaking of? I just showed you above that, hey, this is going to be kind of like 9394 in reverse, and that because our trinomial factored into a perfect square, there are some special shortcuts we can take. So the question becomes, what are these shortcuts? Well, in general, anytime you have a squared plus 2ab plus b squared, this being the general form of the trinomial, anytime you have a perfect square trinomial in this format, it will factor into a plus b squared. A plus b squared. Any perfect square trinomial that has the form a squared plus 2ab plus b squared will factor out to be a plus b squared. Okay, and again, we know a plus b squared, it's worth mentioning, is a plus b times a plus b. Okay, so as we saw above, okay, if a perfect square trinomial is in this format, it will automatically factor into a squared, or a plus b squared, which is a plus b times a plus b. Consequently, very similarly, any perfect square trinomial in the form a squared minus 2ab plus b squared will factor to be a minus b squared. A minus b squared. Okay? So here's our general form. This is kind of our general definition we're looking at. If a perfect square trinomial is in either of these two forms, then it will either factor into a plus b squared or a minus b squared. Now, let me give a disclaimer. If you don't recognize the special cases, once we go through a couple of these examples, if you're going, hey, I'm struggling to recognize whether this is a perfect square trinomial, it's okay. Just factor it like normal. If you think back to 9.3 when we were distributing binomials and then we learned the shortcuts in 9.4, the 9.4 shortcuts were optional. They might save you a bit of time, but our traditional method of distributing binomials always worked. The same is true here when we're factoring trinomials, the opposite of distributing. Okay? If you can always factor a trinomial the same exact way as you learned in 9.5 and 9.6. Always can work that way. But 9.7 just says, hey, if you recognize these shortcuts and it makes your life a little easier, go for it. But understand that the 9.5, 9.6 methods will always work. So, how do we recognize a perfect square trinomial? We've seen the general form, but what specifically are we looking for? Well, the first and the last terms are products of identical factors. The first and last terms are products of identical factors, okay? And we'll see what this looks like in a second. The middle term is going to be 2 times a factor from the first term and a factor from the last term. And these are the two, make sure you have these written down. These are the two criteria we have to meet in order to recognize a perfect square trinomial is present. So let's look at an example. Again, pause the video, go back if you need to finish that writing that definition down. Make sure you have those solid. So let's start here. What are the types of problems we're going to see? Well, let's say I need to factor x squared plus 4x plus 4. X squared plus 4x plus 4. And upon looking at this, x squared plus 4x plus 4, I go, well, I'm going to factor this like normal, right? There's no coefficient up front, which makes my life a little easier. It means I can jump straight to factoring our last term, our constant, c. And I write down the factors 1 and 4, 2 and 2, and I go, which ones are going to add to give me 4? Hey, 2 and 2 will. And so I go, hey, this is going to be x plus 2 and x plus 2. Okay, those are the two factors that multiply to give me 4, that add to also give me 4 in the middle. And again, I can jump straight to my answer because there's no coefficient in front of the x, so we don't have to split the middle, build a wall, anything like that. And maybe I go, you know what, I can rewrite this as x plus 2 squared, since I have two x plus 2's being multiplied together. But the other option would be to take the shortcut, and that's really what 9-7's all about. So there's the traditional factoring method. But let's say I was posed with this problem. I needed to factor x squared plus 4x plus 4. And I keep that shortcut in mind. What's the shortcut? That if a perfect square trinomial is in either of these two forms, it will automatically factor to that. But in order to do this, we have to recognize what is a perfect square trinomial. So let's use that definition of how to recognize a perfect square trinomial and see if this meets the case. Well, let's look at it. Well, the first criteria is I'm going to look at my first term. Is the first term a product of two identical factors? Well, x squared is the product of x times x. So yes, it is the product of two identical factors. What about our last term, positive 4? Can we rewrite that as a product of two identical factors? Well, yeah, we could write it as 2 times 2. Hey, we're so far so good. Now, what's our second criteria? Well, the second criteria is, once you've rewritten your first and last term as a product of two identical factors, take a factor from the first term and a factor from the last term and multiply it. So maybe this will help with the visualization. And multiply that by 2. Well, when I do this, I get 4x. Does that match my middle term? Yes, the 4x's align. And so I have met all my criteria to say, hey, this is a perfect square trinomial. Well, if it's a perfect square trinomial, I can jump straight to my answer. What it's going to be is one of my first factors plus one of my second factors. And this will be my answer. Okay? And you can see here, while you might be adjusting to the shortcut, you can for sure see that the shortcut works. You may or may not like it, but the shortcut and the traditional method both work. Okay? Providing you meet, the traditional method will always work, but the shortcut method will work providing you meet those criteria. Let's try a few more examples. 4x squared plus 12x plus 9. Okay? For the sake of this video, I'm only going to, from now on, be showing the shortcut because that's what 9.7 is all about. But please understand, if you are going through the shortcut and you're going, I don't like it, if you're sitting there going, I don't like the shortcut, then I need you to still watch the video and factor these, but factor them your traditional way. Okay? Factor them the traditional way. Your answer will still match my shortcut. Okay? But for the sake of the video, I'm going to just show the shortcut. If you would like me to check your work on your traditional factoring of this, or you want to see the traditional factoring of this, again, please send me an email and I'll be happy to help. So I'm going to look at this and I'm going to see if I can factor it as a perfect square trinomial. And again, over time, you're going to get good at going, what do I consider, hey, maybe this is a perfect square trinomial, and what do you go, nah, there's no shot, I'm just going to jump straight into factoring the traditional way. Because if it isn't a perfect square trinomial, I have to factor it the traditional way. Don't miss that. If it's not a perfect square trinomial, you have to factor your trinomial in the traditional way. So looking at this, what I notice is, and how I begin to recognize, and you will begin to recognize, hey, maybe this is a perfect square trinomial, is the fact that my last term is 9. Well, I know the square root of 9 is 3. Hey, 9's a perfect square. 4 also is a perfect square. 2 times 2 is 4. So maybe this is a perfect square trinomial. That's what's kind of running through our brains right now. But in order to check that, to check the shortcut, what we got to do is we got to check our 2 criteria. Number 1, can I write the first and the last term as products of identical factors? Well, you're probably sitting there going, well, yeah, I can write 3 times 3. Duh. Easy. Okay? For x squared, a little more tricky. I know I can get the x squared to be x times x, but what about the 4? We'll combine both. Okay? How do we split 4 into 2 identical factors? 2 and 2. Therefore, 4x squared can be rewritten as the product of 2 identical factors, 2x times 2x. So since both my terms can be rewritten as the product of identical factors, I move on to my second criteria. For it to be a perfect square trinomial, not only do I have to have my first and last term be the product of identical factors, but I have to take each one of those factors. So we'll do 2x, one of each of those factors, times 3, and I have to multiply that by 2. Okay, that was our second criteria. This must give me the middle term. If it doesn't, then this is not a perfect square trinomial. So I look at it. 2x times 3 is 6x. 2x times 3 is 6x. Times 2 is 12x. Hey, that does match our middle term. What does that mean? That means I can jump straight to my answer. What's my answer going to be? Well, it's going to be one of my first factor plus my second factor. Okay? A factor of one of the factors of my first term plus one of the factors of my second term. Okay? And there, boom, I have my answer. Again, if you would factor this out the traditional way, you would get 2x plus 3 times 2x plus 3, also known as 2x plus 3 squared. Again, at this point in the video, if you are royally confused, if you're like, man, this makes no sense, 1, shoot me an email so I can help you out and answer your specific question. But 2, never fear, you still have the traditional factoring method to solve these problems. 4x squared plus 20x plus 9. Again, whole idea here is this a perfect square trinomial? Well, I'm thinking we're right on the right track because 4, I know, can be broken down into 2 times 2. 9 can be broken down into 3 times 3. So I'm thinking, hey, this has a shot. So let's check it. First criteria, the first term has to be rewritten as the product of 2 identical factors. Well, 4x squared can be rewritten as 2x times 2x. 9 can be rewritten as 3 times 3. And hey, we've met our first criteria. But before we go any further, and this is where most people screw up, they forget to check their second criteria. You have to take a factor from each term, one from the first and one from the last, multiply it by 2, and if it doesn't equal the middle term, it's not a perfect square trinomial. Well, 2x times 3 is 6x, times 2 is 12x, and our second criteria is not met. Why? Because 12x does not equal 20x. We passed the first criteria, but not the second. What does that mean? Is this unsolvable? Well, no. I can still factor out my traditional way, which I'll show you here in a second. But I cannot factor it using the perfect square trinomial shortcut, because this is not a perfect square trinomial. Otherwise, 2 times one of each of the factors would add to be my middle term. So be careful there. Make sure you check both criteria, otherwise it can hurt you. So since this isn't a perfect square trinomial, I'll factor it the traditional way. There's a number in front of my first term, so I multiply that with my c value, and I get 36. I identify the factors of 36. And now I look at my middle term and go, which ones will add to give me 20? 2 and 18. So I split the middle at this point. I split my middle term into 2 terms. Then again, if I combined the like terms, they would add to be my original middle. Now I build the wall, as we've seen in previous videos. Again, if this, while I'm going somewhat quickly through this, if this is very confusing to you, again, you need to reach out to me. You're a little bit behind, which is okay. We can catch up. Just reach out so that we can get you back on track. 2x is the greatest common factor. And I get 2x plus 1. Factor out a 9 over here. And I get 2x plus 1. And I look and I notice my parentheses are identical. It's pretty good. So I bring the whole band back together. And I'm not rushing, but I'm moving through this fairly quickly because we've seen a lot of these in 9.6. Which again, if you need extra practice with, there is extra practice on Schoology under week 15 with an answer key built in. So you can have a look at that. Last step, both of these terms have a 2x plus 1 in common, so I factor that out in front. Which leaves me with 2x plus 1 times 2x plus 9. And again, by factoring the traditional method, we quickly see that this was indeed not a perfect square trinomial. Otherwise, these factors would have been identical. It would have been identical. Okay, so be careful. If you do not have a perfect square trinomial, watch out. Make sure both those criteria are both met before you try and take that shortcut. Okay, a couple more examples to try together. X squared minus 8x plus 16. Again, if I'm being told to factor this, the alarm bells are going off in my brain because I know x squared can be rewritten as x times x, and I know that 16 could be rewritten as 4 times 4. So my brain's going, hey, might be a perfect square trinomial. Let's try that shortcut. Well, indeed, the first factor can be rewritten as x times x, and the second factor can be rewritten as 4 times 4. But so that we don't get burnt like we did last time, we got to make sure that that second condition is satisfied before we proceed with the shortcut. And when I do this, taking one factor from each term and multiplying it by 2, I get 4 times 2 is 8. I get 8x, and oh, I'm so close. I multiplied that out 2 times one of my first factors times one of the factors from my last term, and I got 8x. But my middle term is not 8x, it's minus 8x. It's a negative 8x. Oh, no. But we're so close. Well, the good news is, folks, there's a way to still make these work. Because if we remember back to our definition, if we're in the form, we've only looked at ones in the form of a squared plus 2ab plus b squared, which factors into a plus b squared, you still can have a perfect square trinomial if it's in the form of a squared minus 2ab plus b squared, and your factors will be a minus b times a minus b, or a minus b squared. With that in mind, let's look back to our problem. Well, I know that right now my second piece of criteria is not being met, so what could I change? Well, the logic is going to go back to an elementary fact of algebra. And it's the idea that a negative times a negative will give you a positive. What am I referring to? Well, x squared equals x times x. We're not going to really mess with that. But what we can look at is 4 times 4 is 16. You see, there's another pair of factors that multiply to give you 16. Negative 4 and negative 4. How does that change things? Well, it doesn't change anything up here. You see, I've still met my criteria of having two identical factors multiply to give me 16. But if I have a negative 4 down here now I get negative 8x, which is the middle term I'm going for. So if you have a negative in front of your middle term, it doesn't mean it can't be a perfect square trinomial. What it just means is that one of your pairs of identical factors has to be negative and negative. So now that we've met our criteria, we can go ahead and write our answer, which is one of the first factors, one of the factors from my last term, squared. Boom, I have factored this perfect square trinomial, despite there being a negative present. Okay, so don't let the negative spook you. You can still have a perfect square trinomial if there's a negative in front of that middle term. We just have to use the logic that a negative times a negative is a positive. Okay, we're going to do one more example, and this is your check for understanding. Again, I don't care if you have been factoring all these the traditional way or you've been using the shortcut with me. Either way, I need you to be able to factor the following trinomial. This is your check. Can you do this? So if you haven't tried one on your own yet, you haven't been pausing the video and trying these, go ahead and pause the video and give this a shot. Okay? Let's check your work. Well, again, I'm going to see if it's a perfect square trinomial because the alarm bells in my brain are going off because I know x squared can be broken down as a pair of identical factors. And 64 I know is 8 times 8, which are identical factors, among the other factor pairs that multiply to give you 64. So I'm going to go ahead and check my criteria. X squared can be rewritten as x times x. 64, I don't know why I changed color. 64 can be rewritten as 8 times 8. Again, pairs of identical factors. So we're good so far. So we jump to our second criteria. And we go 2 times one of our factors times one of our factors. And I get 2 times x times 8, which simplifies to be 16x. And oh, I'm so close. I got 16x, but I need to get negative 16x. What does that mean for me? That means this needs to be negative 8 and negative 8. Okay? That'll still give me the positive 64 I'm looking for, but the negative will also then give me the negative 16x I'm looking for in that middle term. Okay? I need it to be negative 8 and negative 8 so that not only is my last term satisfied, but I also get the middle term I'm looking for. So this is a perfect square trinomial. Criteria are met. So I take one factor from my first term and one from my last, and I get x minus 8 squared. Guys, thanks for watching. Again, the moral of the story is there are shortcuts if you recognize shortcuts in factoring if you recognize a trinomial is a perfect square trinomial. If it isn't a perfect square trinomial, you have to factor it the normal way, which will work anytime. But if it is a perfect square trinomial, based on the criteria we've displayed here, there's a shortcut to factoring it. Have a great day.